All right, hello everybody. So this is just me going through all the problems so you can see how you could have solved them if you didn't, or check your work, or maybe possibly see another way to solve them for the first test in the Big Ideas Chapter 1. Okay, that first one is just a basic exponent. Remember how if we had 5 plus 5 plus 5, we learned that you can write that a different way as 3 times 5. It's repeating the same number while adding. Well, this is repeating the same number but multiplying. So we have 19 times 19 times 19 times 19 times 19. I count them. There's 5 of them getting multiplied together. That is just simply 19. We call that to the 5th power. Okay? Nice to start the test off with an easy one, right? All right, so if you know how exponents work, that was a very simple problem. And this next one isn't too bad either. But remember what the most popular wrong answer is. The most popular wrong answer for 4 to the 3rd power is people get confused and do 4 times 3. That's not what it is, right? That's 4 times 4 times 4, right? 3 times. And I could do that in any order. I'm going to go ahead and do this first and have 16. So now my problem ends up being 4 times 16. If you have to write it over here, do it. It doesn't take that much more, right? You got 24, carry the 2, and 4 times 1 is 4, plus 2 more is 64. 64 ends up being the correct answer on that one. All right. Now when I'm determining if 169 is a perfect square, remember, instead of saying to the 2nd power on these, we can say squared, and the reason is when you get the area of a rectangle, it is just the length times the width, and a square is a special rectangle where the length and the width are the same. So if I got the area of this special rectangle, a square, it would be 3 times 3, or 3 times itself, or 3 to the 2nd power. So we call these squares, right? 3 to the 2nd power is 3 squared. I'm looking for a number squared equals 169. Now I know that a dozen is a gross number. That's 144, right? So I'm just going to try the next one, right? 13 times 13. Just check and see where that is. I want to make sure that my perfect squares, 144 is a perfect square, 9 is a perfect square, 4 squared, 16 is a perfect square, right? 25 is a perfect square. Gross number is a perfect square. I want to see if 169 is. So if I make sure I get the squares on both sides of it, if there are, then I can make sure that it is or isn't, right? So 3 times 3 is 9. I got the right number in the ones place, and 3 times 1 is 3. Put a placeholder down, 1 times 3, 1 times 1, and then we'll look at that. 13 to the 2nd power, or 13 squared, is 169. Okay, and I'm just going to prove it right there with the 13 squared. All right, now this OOO problem, or order of operations problem, is very important. We try to warn everybody that when you see a number next to parentheses, go ahead and put a big dot in there so you remind yourself that's a multiplying. If that's multiplying, then in this problem I have subtracting, multiplying, parentheses, dividing, and exponents. I'm going to do parentheses first. 14 plus 4 is 18. Now, I take the extra 15 seconds, or whatever it takes, I don't even think it's that long, to write what's left, and I do one thing at a time. What's next? Well, the parentheses are done, right? I'm going to have this 8 times 18 in there. I got to do the exponents next. 4 to the 2nd power, most popular wrong answer is 8, right? But the correct answer is 4 times 4, or 16. Now, I had some people not put their dots very good on their division, and they ended up, by the 2nd or 3rd time they wrote it, thinking it was subtraction. Hopefully you didn't do that. Now I have subtracting, multiplying, and dividing, and multiplying and dividing happen before subtraction and addition, right? But which one comes first? Well, they're equals. So which one comes first is the one that lines up first. So I got to do this 8 times 18 first. And I'm going to go ahead and write that over there. There's different ways of doing it. You go 8 times 20, 160, minus 8 times 2, 16, and 160 minus 16. You could do 8 times 8 is 64, and do the 8 times 10 is 80, and 64 4 plus 80 is 144, but I'm doing it this old-fashioned way, this algorithm, and I get 144. Okay, what's left? I got 18 minus 144 divided by 16. Now I'm going to divide before I subtract. So I got to figure out how many 16s fit into 144. This is a tough one, right? All right, now it won't fit into 14 even, right? Bring down the next number, so it's going to be a big number. I know that 16 times 10 is 160. I'm thinking it's pretty close. And 9 times 6 is 54, right? So 9 times 6 is 54, carry the 5, 9 times 1 is 9, plus the 5, ooh, look at that, 14. Perfect fit. So I ended up with 9 as my answer there, and 18 minus 9 equals 9. Now notice how I solve this from top to bottom, one step at a time, and I show each step, and I go ahead and rewrite what's left after each step. Keeping track of everything is a big part of solving these problems correctly. Okay, I definitely recommend you start solving things like this. It'll really help you. You'll have a head start on the other kids when you start getting algebra. Okay, now list all the factors of 84. Oh, I have a feeling this is going to be a lot, and it's true because whenever 12 goes into a number, there's a lot of factors. All right, first one times anything. I always start with that. If it's even, I go to the next number. 2 times what? 42. All right, now 8 plus 4 is 12, and 3 goes into 12, so I got to figure out how many 3's fit into 84. Now, if you have to, do a little long division. Just make sure. 3 goes into 8 2 times. 2 times 3 is 6. Subtract, bring down the next number, and 3 goes into 24 8 times. Perfect fit, right? So I got my 3 times 28. Now I did 2 times an even number, so I know 4 is going to fit into it. And some of you can see that 4 times 21. And 5 won't because it doesn't end in 5 or 0. 6 will because 2 and 3 both did. How many 6's go into it? Right, the other choice is 3 times an even number means 6 is going to go into it. And it's actually half of 28. That pattern is pretty cool to know. 5 won't because that doesn't end in 5 or 0. Does 7? Does 7? Ooh, I think it does, huh? Let's just double check. 7 goes into 8 one time, 1 times 7. Bring down the next number and look at that. 7 times 2 is 14. So 7 goes into it 12 times. All right, now does 8? Nah, 8 times 10 is 80. 8 times 11 is 88. Does 9? Nah, 9 times 9 is 81. Does 10? No, it won't fit, right? And 11 doesn't because 88. So that's it. That's all of them. Now it says to list, so technically you're supposed to say 1, 2, 3, 4, 6, 7, whoops, 6, 7, 12, 14, 21, 28, 42, and 84. Technically, that's what you're supposed to do. Put them in a list, okay? All right, but if you got all these, I probably gave you credit. All right, prime factorization is 688. Yikes, that's a big number, but don't be too afraid of it. Each time you do one number, it's going to get smaller, right? So I'm going to go ahead and get rid of it, half of it with a 2. How many times 2 go into it? 344, right? I can get half of each of these numbers, right? 344. Now, half of these is a little harder, so I'm going to go ahead and divide the 2 into 344, and 2 goes into 3 once. 2 goes into 14 7 times. Perfect fit. Bring down that last 4 and 2. So I'm going to hit 172 on this one, right? 172 still even, so I know 2 goes into it still. You want to divide 172 by 2? All right, now you can do this. Now some kids will take a shortcut because they know a bigger number goes into it. That's fine, but if this is a test and you can't figure out, do a little work. It's worth it, right? So I got another 2 here, and this goes 86, and 86 is also even. Now that one you can probably do in your head. Half of 86 is 43, and guess what? 43 ends up being prime. So I need to put these in order to get the prime factorization. Don't lose all these. 2 and 2. That's why it's really good to circle them. 2, 2, 2. Circle them. 2. 4 2's, right? 2 times 2 times 2 times 2 times 43. And if you want, you can write that, what do we call it, in exponential form by saying 2 to the 4th power times 43. Box that answer. Greatest common factor of 94 and 14. I'm going to go ahead and make factor trees, use a prime factorization on this, right? And I got 2 times 47 here. And for 14, I got 2 and 7. I know both of those are prime. And guess what? 47 is prime. So the only pairs I have are those 2s, 2 and 47. Remember, greatest common factor, we're going to stack them and look for matches. And we count that once. So 2 is actually the biggest number that fits into both 94 and 14. Because 94, doesn't, as big as it doesn't have a lot of choices, right? All right, these common multiple, I'm going to list those because they're small. Remember, if they're small, I do the list the multiples, 4 times 2, 4 times 3, 4 times 4, 6 times 1, 6 times 2, ding, 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 right? So that's going to be 12 on that one. You could do that using prime factors, but again, with the smaller numbers, I use the list of multiples. With the larger numbers, I will use the prime factorization. All right, each face of a cube is a square, right? That's like a die, right? Right? You play dice, Monopoly, Yahtzee. These are probably old man games, huh? All right. So you got your dice, right? There are 6 faces, right? 6 numbers. Each face is a square that's 7 inches by 7 inches. What is the total area of all of the faces? Well, that one face is 7 inches times 7 inches, or 49 square inches. That's one face. I have 6 faces, so I have to go 6 times 49. If you slow down and thought about this, you would have got it, right? So 54 and 24 plus 5, 29, 294 square inches. Don't forget, it's always square units when we're talking area. All right, that last one on this page, right? A power that has a value greater than 215 and less than 220. Now I know 15 times 15 is 25, 215. Oh no, it's 225, huh? And 14 times 14 is 196. So I'm thinking that's impossible. But that's only to the 2nd power. Those are squares. I can go to the 3rd power, right? So 5 to the 3rd power, right, is 5 times 5 times 5, which is 125. 25 times, that's 5 quarters, 125, right? So I'm just going to keep going up. That seems too small, right? So I'm going to try 7 to the 3rd power. That's 7 times 7 times 7. That is 49 times 7, which is almost 50. That's going to be up to 350, right? It's actually 343. So that's too much. I'm trying this one in the middle, see if the 3rd power works. Might have to go to the 4th power, huh? 6 to the 3rd power is 6 times 6 times 6, or 6 times 36. And 6 times 6, we just said, is 36. Carry the 3, and 18, and 3 is 216. That is bigger than that, smaller than that. So 6 to the 3rd power works there. This is one of those, guess and check just to make sure. It didn't say, is there one? So we're assuming there should be one. So I'm going to try a few until I find one and hopefully not give up. Okay? 2nd page. You have a square vegetable garden with lengths of 9 feet. I swear, if you can draw a picture on a problem, do it. Almost always helps you understand it. You plant flowers in the center portion of the garden. I'm recording. In the middle, and it is 5 feet. So in the middle here, I'm making one that is 5 feet by 5 feet. Okay? So that's a square. Now it says you divide the remaining spaces into 4 equal sections and plant tomatoes, onions, zucchini, and peppers. What's the area of the peppers? I need one of those sections. I have to get the area of one of those sections. Now I could do this. and have 4 equal areas. But then that's a trapezoid. You know how to get the area of a trapezoid? You say, no, not yet. Yeah, you say yet, right? So instead of doing those right like that, I'm going to do this. Right? Okay? And now I have, if this is 5 and the whole thing's 9, each of these sides is 2. So this is 2, this is 2, and if that's 2 and then this whole thing's 9, that must be 7. So one of these is going to be 2 times 7. Right? And what's 2 times 7? 14 square feet. Now, another way to solve this, okay, is the entire plant or vegetable garden you have is 9 times 9. And that's 81. The middle part that we're going to put flowers in is 5 times 5. So what is left ends up being 56 square feet. Okay? And I'm going to divide that into 4 sections. You can do 56 divided by 4. Okay? You could have kept your nice trapezoids, right? If you wanted. Then all you have to do is 56 divided by 4, and guess what? It goes into 5 once. Bring down the 6, it goes into 16 4 times. So you get the 14 that way as well. Okay? But drawing a picture really helps. Okay? Don't draw pictures of little aliens and stuff and other things I see on your papers sometimes. Draw a picture of the problem. It is a real proven strategy to help you do better on some problems. Okay? All right, back to the next one. The greatest perfect square. This was a tough one. That's a factor. So I'm looking for a perfect square. Remember those perfect squares? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, right? I'm looking for the biggest square number that goes in there. Now, it doesn't say there isn't one, right? So I'm going to check. Do these fit, right? Right? 7 times 7, 8 times 8, 9 times 9, 10 times 10, right? What other numbers are going to fit in there, huh? Right? Does 144? Nah, man, right? Because 11 times 11, 12 times 12, right? These are ones that's good to know these squares. I'm going to see if these numbers fit into that. That's one strategy. Another strategy is you just get all the factors, right? And make a list. 1 times 448, 2 times 224, right? That gets kind of hard, right? So what's going to fit in there? Well, it turns out after a lot of guessing and checking, some people got the 16, some people got the 4. Those are perfect squares. They fit into there. Okay. I know 25. I'm not even going to try that because those are going to end in 5 or 0. And 4 plus 4 plus 8 is 16, so 3 doesn't go into it. So 9 won't, 36 won't, 81 won't, right? Because 3's goes into those. So what do I got left? I got 49, 64, 100. Right now I'm moving towards the 16, but let's try 49. 49 times 10 is 490. 49 times 9 is 81, 36, and 4, 440. Well, that's too small, so 49's not going to fit. Okay, 64, 64, how many times is that going to go into that? Well, I'm picking a 6 times 7 is 42. Let's try 64 times 7. And that's the right spot, right in the ones place. That's an 8, right? So 28, carry the 2, and 42 plus 2, 44, boom, boom, boom. 64 ends up being the biggest perfect square, right? Because remember, 8 squared is 64. And it is also a factor of 448. All right? All right, tough problem, I know. Some of these were tough. In fact, 15 was so tough you can cross that out. All right, back to the filling picnic baskets, right? You have 18 sandwiches, 24 granola bars, and 42 apples. You want identical groups of items in each basket with none left over. What's the greatest? Well, what is this? This is the greatest common factor problem, huh? So I got 18, 24, and 42. What's the biggest number that goes in all three? I think it's going to be 6, but let's try it this way. 3 times 6, 2 times 3, 3 times 8, 2 times 4, and the 4 becomes 2 more 2's. Right? This is 6 and 7, and 2 and 3. All right. So when I stack these, you stack them for the greatest common factor, right? 2, 2, 2, 3, and then 2, 3, 7. Right. So I got 2's in each and 3's in each, and that's it. 2 times 3 is 6. 6 is the biggest number that fits into all three. All right. All right. The next one, the bus. Oh, the bus. Remember this thing happens at the same time, and then they go off track, and when are they lined up again? So the stop A is every 14 minutes, and other bus stop B every 20 minutes. Okay, they both have stopped 5 minutes ago, so it happened all at the same time, but that's going to be important. After how many minutes will the bus arrive at the same stop again? Okay, so it's really a least common multiple problem of 14 and 20. Okay, and I can do greatest common factor here, right? And let's do 4 and 5, 2 and 2. So I got 2 times 7 and 2 times 2 times 5. Which side has the most 2's? This side. Cross out that one. This side has the most 7's, there's only one. This side has the most 5's. So I'm going to go 2 times 2 times 5 times 7. I'm putting that 2 and 5 together because it's a 10. And 2 times 10 is 20. And 20 times 7 is 140. But before you circle that and say that's the answer, remember we're starting not at 0. We're starting 5 minutes later. So I got to go back 5 minutes. That 140 I have to go back to get to 135. Now, one way of getting least common multiple is to do what I did. Do the prime factorization and then find out which side has the most and circle and cross out, right? Another way is just list multiples, right? So if I were to list the multiples of 14, I'm going 14 times 2, 14 more is 42. I saw some kids do this. Great job. Some of them were on the track and then they misadded a 14 or here or there, right? Right, so I'm doing this, right, and I'm actually, because I know that next one's a 20, I'm looking for a number that ends in 0. 70 ends in 0, but I know 20 won't go into 70, right? So I'm kind of looking for a number, and there's another one that goes into, right, and 14 is 2 goes into 14, so 140 is going to be my answer, right? Right, and that's another way to get to the 140, and then you just have to make sure you subtract that 5 minutes again. A third way I saw, interesting way a kid did it, they did it like this, but they said, okay, 5 minutes ago plus 14 is going to be 9. And then 5 minutes ago plus 20 is going to be 15. Now I add 14. 23, 37, 51, 65, 79, 93, 107, and then 121 and 135, and here I'm going to go 35, 55, 75, 95, 115, and 135. Cool way of doing it I hadn't thought of, so thank you whoever did that. I forget who it was. So I threw that one out. That's a volume problem, okay, and it's a volume with converting cubic units, which is kind of crazy because 1 cubic yard ends up being 27 cubic feet. So crazy problem. Yeah, I don't know why they threw that in there. All right, so that's it. Hopefully you understand how to get those problems right next time, and hopefully you got a lot of them right already. Okay?